Well, hello everyone. I guess everyone knows Doom and how it changed everything. But little is talked about how the code behind it changed what is good practice and what we should know to properly code a game to keep it fresh regardless of how many years was launched. In 1993 was launched what was one of the earliest FPS of the game's history, and it changed not only the genre but all the game industry on its standards. Okay, but what is Doom? Doom is a classic first-person shooter video game developed and published by ID Software in 1993. It is widely regarded as one of the most influential video games of all time, popularizing the first-person shooter genre. In Doom, the player will take the role of a space marine who is tasked with fighting off hordes of demons that have taken over Martian research facility. The game is set in a fast-paced gameplay, and the player uses a variety of weapons, including a shotgun, a chain gun, a rocket launcher, to defeat all types of demons and progress to the level. The game had a strong impact of culture of modern games, musics, and every other overall culture. Before Doom, every other game that was supposed to be an FPS game was slow, methodic, and had only one way of looking, always vertical. And the designers of Doom didn't want to follow the same direction as, for example, Quake, and wanted the player have the feeling of direction, left to right, up and down, like a 3D. Wait, a 3D game? But anyways, did you realize when you play Doom, you can never look up or down? That's right, because the game is not really 3D, but yet a fake illusion that you are in a 3D world. The planes of the game are not quite what you think. It's called 2.5D. The sprites are 2D, but the play is also presented in a 3D perspective. Doom also started allowing players to compete against each other over a network or modern connect. But anyways, we could talk the entire day about all the techniques to save memory that was used on this game. And trust me, the game, it is huge on saving memory. But that's not quite the point, right? Doom was created first on the NCC language, started on X workstations, and the fine game engine was programmed in C. The creators of the code behind it was John Carmack and John Romero, with Carmack creating the bulk of it. We shall not confuse C and NCC, since both are kinda different. NCC was a kind of an old version of what we know as C. Okay, but let me explain something. The game did a lot of things, and it's good that we talk about it, but this is not the focus of the video. It revolutionized the code industry and everything else, but how can we look at it and say, he created so many ways of doing good manners in your code, so you you know spaghetti everything and find yourself trapped in a game full of bugs. Well, but since we are here, why don't make a quick summary of what happened. We all know those great looking games you have nowadays and great 3D models and everything else, but do you know what happens behind the great curtain we call code? The questions that everyone makes. How do we make this computer run Crysis 3? Every nowadays graphic cards usually has 64 or 128 bits, or let's call it compute units just for the sake of it, and each compute unit runs 1200 million instructions per second. These make all the fancy 3D graphics calculations we see. Carmack did it in a computer of 93 with one compute unit. The compute unit runs 10 million instructions per second, and they were used on every general purpose of the PC was not only for the game. Doom was not 3D, but again, fake illusion of 3D, because the game would not run on those computers. Doom was one of, actually, no, Doom was the father of the FPS games, since it was never really done it before, with the exclusion of Wolfenstein that we can say are kind of twin brothers. The reason why no one did it before? Well, it was way too heavy for a computer of that time to run a game of fast-paced gameplay like this before. A lot of games that came after Doom and was FPS had to wait for the upcoming generations of consoles and computers, because actually no one could redo what Carmack did. Well, but let's talk about the interesting stuff. And first, let me say one of the biggest reasons why I'm doing this video. Doom is open source. But you can argue, okay, that's cool, but what is special about it? Well, we can start by making a list of everything that Doom was released. Nope, you didn't hear it wrong. Yes, everything. Not every console, not every PC, everything. macOS, Microsoft Windows, Sega 32, Super SNES, PlayStation, Switch, TempleOS, iPad, Minecraft headstone circuit, gym treadmill, smart microwave, smart fridge, GPU drivers, thermomixes, pregnancy tests, toasters, billboard trucks, calculators, thermostats. Yeah, Doom was supported by everything that has a chip and some wires. The ability of making a clean and open code made possible for programmers all around the world to keep his work and part by everything on this universe. They even have a subreddit for it. Why don't you check it out? But wait, clean code? What is it? Is there such a thing called clean code? Yes, of course there is. Keeping your code clean is more than necessary to make it easy to read, understand, and maintain it. Writing clean code is important because it reduces the chance of introducing more bugs because, trust me, they will be there regardless of what you do. And well, makes it easier to work with more people around you. We can use the following examples and talk about them further. We can use descriptive and meaningful variables and function names, breaking up code into small cohesive functions, minimizing the use of comments, and formatting code consistently. As we saw before, Doom was made to be readable, reusable, and scalable, and that one makes Doom a good code to learn. One of the things that we can learn from this code is commenting. Commenting was insanely precise. We don't need to know what every single line of our code is to understand what's going on. Come on, you don't need to understand what is a boolean. We know what is it. Everyone learned that comments are sacred and they need to be there on the mess you call game. But let's be honest, not always. We do need to learn that people are going to read your code need to understand it and not read green lines of a monstrosity explaining why your function is called take damage. We know why. But okay, let's be honest, code is necessary. Let's just talk about how it helps not only you, but assuming you work with other things we call humans. Comments are particularly useful for complex or non-obvious code that requires additional explanation. They can be also helpful for indicating the purpose of section of code, or providing context for why certain decisions were made. However, we need to make sure that everyone understands that comments should be used justly and not substitute for clear code. Over-commenting can make the code harder to read, so a balance is more than necessary for it. We will talk about more of details on the next video of this short series of good manners and how we can learn from old games, but for now, let's get this lesson right and make sure that we understand why commenting is necessary. Alright, and last but not least, I want to make one thing really clear. Not all the game was amazing because it was open source. The game was open source because it's amazing. One of the greatest piece of work that is in his code, for example, is the invention of the fast inversions for root, a method that we shall explore further on the second video, would be more a theory video than explanation. But I think we're done by now, so I see you on the next video.